Here's a solution for day 3, problem 1. Use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. Synthetic division is a division technique where you only write down the coefficients of the different terms of the expressions. You don't take the time to write the variables down. Synthetic division only works when you're dividing by a binomial where the leading coefficient of the binomial is a 1. Now that is what we have here. So we can use synthetic division to divide this polynomial by this. The way synthetic division works is to take the coefficients of all of the terms of your polynomial and to write those coefficients in decreasing order of degree. For instance, the x to the fourth power is the highest degree term. Its coefficient is 1, and so you write down 1. After x to the fourth power would be x to the third power, and there is no x to the third power term, and so that's like having 0 x to the third power, so you record a 0. Now we have the x squared term, and its coefficient is negative 10. Here's the negative 10. Next comes any x terms. Its coefficient is negative 2. And finally, the constant term is that positive 4. So I have listed the coefficients, working my way downwards to the constant term, and the 0 comes from the fact that there was no x cubed term. Then create kind of a bracket symbol. It's almost like an upside down long division symbol. The number that we're going to divide by is going to be written out front here. And what you divide by when you have the binomial x plus 3 is you divide by whatever number for x would make that expression be 0. So like what number plus 3 is 0? X would be negative 3. So we're going to divide by negative 3 out here at the beginning. Okay, synthetic division is a process that involves adding and multiplying numbers. It works like this. Bring down the first number, 1. Multiply together those two numbers and record the answer underneath the next coefficient. Then add these together, negative 3. Multiply these together to make positive 9 and record that result under the next coefficient. Now add these together. Negative 10 plus 9 is negative 1. Multiply these together, negative 1 times negative 3, and record that result under the next coefficient. Now add these together. Negative 2 plus 3 is positive 1. Multiply these together and record the result under the next coefficient. And then add these together. 4 and negative 3 makes 1. This process is called synthetic division. Now we have a bunch of numbers here, and we want to interpret these numbers back into a polynomial form that involves variables and exponents. Here's how that works. You're going to take that last number here, which is thought of as the remainder of the division, and kind of chunk it off separately to the side. Okay, just kind of think of this being separate from these pieces. Then, working from this spot to the left, this is the constant term of the answer to the division problem. This is for the x term. This one is for the x squared term, and this one would be for the x cubed term. So we have 1 x cubed, which you might just write as x cubed. You don't have to put a 1 in front of it. Then we have negative 3 x squared. Then we have negative 1 x. You might just say negative x instead of saying negative 1x. And then we have a positive 1, or a plus 1. Then take that thing that we had chunked off to the side, which is the remainder, and add it on as a remainder. 1 out of, and remember how we divided by x plus 3? So 1 out of x plus 3. This is related to long division, which hopefully you remember doing a lot of in middle school and maybe a little bit of in algebra class. So when you take this 4th degree polynomial and divide it by x plus 3, it creates this 3rd degree polynomial with all of these terms. And this one on the end is how you express the remainder. Now day 3, problem 2. Evaluate the expressions. For question A, we have log base 2 of 16. We have a base 2 log of 16. And we want to find the value of this. Log is a short way to write the longer word logarithm, and logarithms are related to exponents. Here's how logs work. 2 to what power makes 16? Evaluating a logarithm means to figure out what power is necessary to raise the base to get that number right there. So 2 to what power makes 16? 2 to the 4th power is 16, and so the value of this log is 4. The log base 2 of 16 is equal to 4. Question B, ln means natural log. It's a quick way to write out the words natural log. And it's a kind of logarithm, but the base of the logarithm is base e. Base e, instead of having a whole number like this as the base of the logarithm. So instead of writing log with a little e by it, the way to show it quicker is to write ln, natural log. So remember, the base of a natural log is e. So let's ask the question, e to what power makes e to the 3rd power? E to what power makes e to the 3rd power? And that answer is 3. Natural logs have base e. E to the 3rd power equals this expression. Question C, another natural log. The base of a natural log, remember, is e. It's like having log with a little e here, the base. These are equivalent to each other, but instead of writing log base e, we write ln for natural log. So let's ask our same question that we always ask when evaluating a log. We take the base and we ask ourselves, e to what power makes 1? E to what exponent equals 1? That's what we're trying to figure out. What's the exponent required here? Well, hopefully from algebra you remember a rule that said any number raised to the 0 power is equal to 1. And so that exponent has to be a 0. And so the natural log of 1 is 0.